Now let's talk about the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Think about it, it only makes sense because, and in a way it's almost like an extension of our triangle sum theorem, because if we know that two angles are congruent, then they add up to the same number, and if we know that all three angles always have to add up to 180 degrees, then the remaining angle in those two triangles has to have the same value. Let's use a sketch to make this theorem a little clearer. I'm going to draw these two triangles that are supposed to be congruent. If we know that these two angles are congruent and these two angles are congruent, then we also now know that these two angles also have to be congruent. And beyond that, if we know that, for example, this angle has 60 degrees and this angle has 70 degrees, then we know that this angle has to be 60 and this angle has to be 70, and we can also use the triangle sum theorem to figure out the remaining angles. 60 plus 70 is 130, and 180 minus 130 is 50. So that tells us that this angle has to measure 50 degrees, and so does this angle, right? Pretty neat. We only had two numbers in the beginning, and now we have all six measurements. Let's look at these examples. Use the third angles theorem to solve for the variables. In example 4, see how angle A is corresponding to angle D and also congruent. Angle B is congruent to E, and angle C therefore has to be congruent to angle F. Let us make that mark here to indicate what we just found out. Well, first we need to figure out what angle C is, and then we can also derive from that what angle F is going to be. In other words, 110 plus 30 is 140, and that means that angle C has to be 180 degrees minus 140, which is 40 degrees. Angle C is 40 degrees, and if angle C is 40 degrees, then so is angle F. And clearly we also know, and we can write that down as well, that angle D is 30 and angle E is 110. So be careful here and note that the angles not necessarily look like they were in the same order. Again, remember, orientation is not a necessity, a requirement for two figures to be congruent. But we have the information that two angles are congruent, two pairs of angles are congruent really, and therefore the third angles also have to be congruent. In example 5, we're only told that angles F and K are congruent, but if we look at that drawing, we see that angle M really represents two vertical angles, so these two angles also have to be congruent, and if we have, again, two pairs of congruent angles, then the third angle in each triangle also have to be congruent. So if angle T is congruent to angle D, we know that X has to be equal to 65 degrees. And that answers the question for us. Let's then talk about the properties of congruence. First property of congruence is the reflexive property of congruence, and all that really says is segment AB is congruent to itself. Looking at this drawing here, we can make a congruent mark, and really all we're saying is that this segment AB is congruent to itself. Now we could also have two triangles that don't touch each other. The triangles had been like this. Then segment AB would still be congruent to itself. The symmetric property of congruence tells us that if the segment AB is congruent to the segment CD, then the segment CD is also congruent to AB. So all we're really doing here is we are switching the two segments from left to right across the congruent symbol. We're still talking about the same two segments being congruent to each other. And our third property of congruence is the transitive property of congruence. Transitive property of congruence is related to, you remember from our first unit, the law of syllogism. Let's look how it works. If AB is congruent to CD and CD is congruent to FC, then AB is congruent to FC. In other words, we have the link here, segment CD is the link between the two first statements, and we can cross that out, and therefore we can connect segment AB to segment FC and make the statement that segment AB has to be congruent to FC. Remember, that's also how the law of syllogism works. These three properties, the reflexive property, the symmetric property, and the transitive property of congruence, you have met before in algebra. You have met these three very strange seeming properties sometimes in algebra 1 before, and maybe, hopefully, you have learned this little jingle to remember them better. RST 1, 2, 3. R stands for the reflexive property, S for the symmetric, and T for the transitive. And if you look at them a little closer, you realize that the reflexive property only has one element that it's dealing with, in this case segment AB. The symmetric property has two elements that it's dealing with, in this example segments AB and segment CD. And the transitive property has three elements: segments AB, segment CD, and segment FC. Think about RST 1, 2, 3. That works here in geometry exactly the same way as it worked in Algebra 1. And that can be a good way to remember and sort them the right way. In these next examples, we have to use the properties or theorems to mark the pictures with any extra information about what might be congruent, and then write a congruent statement if that's possible. Let's look at example 6. In example 6, we see that angle A is congruent to angle B. Angles M are both right angles, so they're congruent. And angles Z are also congruent. Let's look at the sides. We have the segment AM, which is congruent to the segment MB, and we have segment AZ that's congruent to segment BZ. We have no congruence mark for segment MZ, but if we look at it, we see that it's really, for both triangles, it's the same segment, so we can mark it congruent following the reflexive property. So segment MZ is congruent to segment MZ, and this is the reflexive property. And with this we have marked all corresponding parts congruent, and therefore we can now write our congruent statement. Triangle AMZ is congruent to triangle BMZ. Let's look at example 7. In example 7 we have 3 pairs of sides marked congruent. We have not been given any information about the angles, but if we look, we see that the two segments JH and BN are parallel. And since these two segments are parallel or are parts of parallel lines, we remember and we can use some of our special angle relationships that we have learned in previous lessons. So if we look at HB being a transversal between these two parallel lines, we can therefore conclude that angle H and angle B have to be congruent because these two angles are alternate interior angles. So angle H is congruent to angle B, and we are in luck and we have another transversal, and this other transversal allows us to conclude that angle J and angle N are congruent. Angle J is congruent to angle N, and both of those findings were based on the alternate interior angle theorem. Even though we use two different transversals. Funny how that works sometimes, isn't it? And now let's keep looking, and we need to figure out what happens to our remaining angle. And here we can clearly see that this angle and this angle again have to be congruent because they're vertical angles. And we are going to be careful this time, and we're going to write it so there are no possibilities for confusion. Angle HYJ is congruent to angle BYN, and that's because they're vertical angles. And we are using the vertical angle theorem to figure that out. And now we have all of the parts, all of the corresponding parts marked congruent, and can therefore say triangle HYJ is congruent to, now again, be careful. We started with H, so we now have to start with B, go to Y, and end in N. Triangle HYJ is congruent to triangle BYN. In example 8, everything is pretty much marked. All 3 pairs of sides are marked congruent, and 2 pairs of angles are marked congruent. There's only one angle in each triangle missing, and if we have 2 pairs of angles that are marked congruent, we can use the third angle theorem to conclude that angle S has to be congruent to angle Q. Or if we want to be a little bit more specific, we're not just going to call it angle S, we're going to call it angle KSL is congruent to angle AQP, all based on the third angle theorem. And therefore we can conclude that triangle KSL is congruent to triangle, and I'm going to let you stop the video here and fill in the letters in the right order yourselves. Hopefully you came up with the same order. Triangle KSL is congruent to triangle AQP, and you may have seen that the order of the letters was the same as in the angles that are congruent above. That's also a good help, but make sure that we always pay extra attention to keeping the order of the letters correct so we don't lose any points. For your summary, I want you to use your own words and describe what it means for two figures to be congruent, and also spend a moment to think about where outside of the classroom, in the environment, in the world around you, do you see congruent figures. That concludes today's lesson, and I will see you in class.